Xin chào. Hi everyone. Thank you for joining us today. I know you have a tea break after this, so I'll take just 30 minutes. I'll just take your 30 minutes, and today I'll be going to talk about how to run AI agents in Sandbox on Kubernetes. Now, the previous talk that you just had, the 4Cs of cloud native, that has already set up some context for you, and we are going to see some of those primitives, and I'm not going to spend much time on those slides. So that has already set up a base for me. So I'll move ahead. I'll start with my introduction. I am Aditya. I'm working as a senior software engineer at Walmart. I've been working on Kubernetes from a long, working on distributed systems, and recently started working on the AI projects as well. So what we are going to cover today, the problem statements, why we want to run AI agents in Sandbox, then some primitives of Sandbox, how we can have defense in depth, and then a live demo after that. Okay, where is the next? Okay, so we'll start with the problem statement, like how you can run or why you should consider about running AI agents on Kubernetes. So suppose your AI agent just wrote a command, rm-rf/, and we have been running AI agents in our day-to-day tasks for writing up code, on our local machine or doing something, right? And assume that you are using AI agents for writing up some code, and your AI agent just ran a command rm-rf, right? So what this command is going to do, essentially it's going to delete everything from your root directory, right? Your system will be completely wiped off, right? And nobody asked this question, you won't be caring much about this problem unless you encounter it, right? Unless this problem goes into the production. So let's talk about the anti-pattern that has been shipped so far, right? As a developer who is building any AI agents, what we typically do, right? We ask our LLM agent or LLM that, we want to achieve certain tasks, right? And AI agents give you that code, and then you execute that code. Now, if you execute that raw code which is given to you by AI agent, it can blow up, right? It can go wrong. It can delete something from your machine, or it can do something malicious, right? So this has been the pattern that has been, shipped across a while, even if you are using, for example, Claude code for writing up your code, right? That Claude code is running locally on your machine, and if sometime it gives you a malicious command, it runs that command, some bad things will happen. And the obvious answer to this problem statement would be that why not use containers? We have been using containers in industry from a long, deploying your applications. When the era of containerization came, the Kubernetes came, Docker came, we started deploying our applications onto the containers, right? So why can't we just deploy the AI agent onto the containers, right? But the problem still exists, right? So when you deploy your application or the AI agent into the containers, you have to deal with different set of problems. Problem like, how do you ensure that multiple requests, you want to ensure the isolation of the request as well, so that no same request should go to the same container or same instance, right? We also want to ensure that the service account token is not shared with the APIs, or there should be some restrictions so that if the service account token is there, your AI agent can make call to the Kubernetes, right, if you're running that on the Kubernetes. We just saw in the previous 4C demo as well, where the token was exposed and you were able to make Kubernetes API call, like listing the namespace, pods, and all those things, right? And if a crash happens to your agent or the container, your entire application will go down, right? So these are the problems we are trying to solve, right? Running AI-generated code in production looks fine, but obviously it's not fine until unless it bites you back. Let's talk about the threat model. What potential threats can be there when you try to run your models or AI agent in the containers, the blast area, right? So when your application crashes, right, your container crashes, your entire application goes down, right? And what we need in this case is ephemeral containers, which means that these containers should not be tied to any storage. They should be disposable. They should come. They should do whatever they are intended to do, and then they should be disposed, right? The problem of the secret exposure, your environment variables, your credentials, your service account tokens, if they are being exposed, then AI agents or malicious calls can be made to the underneath system, and potential details will get leaked. The kernels escape. So if the containers are running on a shared host kernel, right, they can bypass the host, the user kernel space, and then can enter into the host machine itself, right? They can bypass that layer. And what we need in this case is we need something called as gvisor, which allows you to run containers in a sandbox environment. Then something called as resource abuse. So if your container, if you don't set up limits or thresholds onto your container, then there can be a resource starvation where your container can blow up the resources. It can take indefinite amount of memory or CPU. And then multi-tenancy as well. How do you ensure that any operation that if there are concurrent operations or concurrent requests that are being made to a container, they should not be talking to each other, or there should be some sort of isolation. And to solve this, there comes the Agent Sandbox. Agent Sandbox, the whole idea of the Agent Sandbox is if we can run our agents, AI agents on the Kubernetes itself, right? So AI Sandbox is a Kubernetes SIG project. It's an open source project, and it treats all these problems as an infrastructure problem, not the application problem. So you, as a developer of these AI agents, you don't have to deal with all these problems. Rather, they should be handled at the infrastructure level. And this project was entirely meant for executing the agent code, the agent generated code. So the whole idea is that you should be confident enough that you can run your code onto the Kubernetes with the help of this project. And if you want to use this project, you have to define everything, like we'll be talking about the primitives, everything as a custom resource definition or a Kubernetes custom resources. So let's talk about some of the primitives. When you want to deal with Agent Sandbox, what are the few things that you have to deal with? The first thing is, when you are getting started with the Agent Sandbox, the very first thing that you will encounter is something called as sandbox template. Now you can think of this as a blueprint for your agent environment. So if you see this particular code snippet here, I have defined, if you have worked with Kubernetes, you will find it pretty much close to a pod spec, right? You will see there is a spec section, then there is a runtime class. The auto mount service account token is set as false. We saw this in the previous presentation as well. And then I have enforced resources as well, like how much should be the threshold for my sandbox, which is going to run, right? So I've defined everything into this template. Now this is a template, right? And just like what we have container images are not, they are just an environment, right? But when you actually run them, you call them as containers, right? So same applies to the sandbox as well. This is a sandbox template, but when you actually create an instance of that is called as sandbox, the actual sandbox. The other thing that you are going to, let me go back, okay. The other thing that I have set here is, I have set the security context as, and defined it that the container or the sandbox should run as non-root. I have defined the seccomp profile as well. I have dropped all the Linux capabilities. So if you can see this particular line, so I have dropped all the capabilities. And I have also allowed privilege escalation to false, mounted the root file system as true, right? So the root file system should be always going to be read-only, not a write-only, right? And this is how we have kind of hardened the environment itself, right? We have seen the limits, the runtime class, the seccomp profile, the capabilities are being dropped. And once you have all these, that completes the entire template, right? Your sandbox template is ready. Now we can go ahead and start using the sandbox. But before this, there is something, one more important concept that we have to learn, which is sandbox worm pool. Now, if you have ever worked with Kubernetes, you know that whenever you try to create a pod, it takes few seconds for you to come up, right? Maybe 2 seconds, 5 seconds, or 10 seconds, depending on the size of the image and different properties, right? But we don't want that latency, right? Because anytime if your AI agent generates a code, you want to get the output of that code immediately, right? You don't want to wait for 10 seconds, 5 seconds, right? That creates a bad UX. And to solve that problem, there comes the sandbox worm pool. Now, if you see this particular sandbox pool here, so here I have given the reference of my same template, right? So this is the name of the template that we saw in the previous slides. And then I've defined the replicas as 2, which means that this is going to ensure that there are always 2 instances of my sandbox at a given moment, right? And with what properties? All the properties are being defined in the template. So there will be always 2 instances of the sandbox environment ready for me with the configuration that I've defined in the template, right? And that is why this is called as worm pool, because you always going to have that many instances, whatever you have defined, always ready for you to serve your request, right? Now the third component that comes into picture is the sandbox router. Now you can think of this as a broker which receives all the requests from your client application and then forward it to the sandbox controller, right? And this should be the only way for your agent to communicate to the resources into the Kubernetes, right? So if your AI agent is generating any code, it should always talk to the sandbox router, and then router is going to make the claims onto the worm pools that are already there, meaning the instances that are already there, and then get the code executed for you, and then give you the response back. Now, how it all fits together, this is what I was trying to explain. Your AI agent just wrote a code, it generates something. Then you can integrate it either with Python SDK of the agent sandbox, and there is a Golang SDK as well. And the request goes to the sandbox router where it sees this request has to be forwarded to which particular worm pool. Then it makes a claim onto that worm pool. The worm pool gets that request, and your untrusted code gets executed there. And once your code gets executed, the response is again sent back to the AI agent via the sandbox router, and the instance where the code was actually running, that will get terminated automatically. And you will again, that moment, you will have one more instance of the worm pool. So worm pool always ensure that you have the minimum number of replicas or minimum number of instances that you have specified available for you to serve your request. Now, let's see how we can ensure defense in depth. So we can use something called as gvisor. It's a runtime class. It was created by Google, but now it's an open source. You can install it. So we are going to create a runtime class, and we can point our sandboxes to run onto these gvisor enabled nodes, right? So in Google Cloud at least, and this thing is available in other clouds as well, you can create runtime classes, and then you can ensure with the help of node selector that anytime if your pod matches those conditions or the node selector conditions, the pod will get scheduled onto those particular node itself, right? So we can always pin our sandboxes to the gvisor enabled classes. And let's see how the layered stack actually looks like. So for runtime related issues, we can use runtime class that allows us or the container that they are never going to go into the host level kernel. Rather, they are going to always reside into the user space kernel. For identity issues, we can always disable the service account tokens that allows AI agent to not make any API call to the Kubernetes resources. For privileges, we can drop the capabilities, the Linux capabilities. For resources, we can definitely set the resources, the CPU and the memory limits so that there is no resource starvation. And for placement, like where these sandboxes should actually be placed, we can set up node selectors and the tolerations. And most of these concepts that you see here, these are coming from the Kubernetes fundamentals itself, right? So most of them are coming from the Kubernetes, and Agent Sandbox allows you to ensure that you always run in a in an isolated environment by using these capabilities. I have a live demo. I'll present it like in few minutes. But before that, I'll show you how to run that demo actually. So I already had a Kubernetes cluster with me, and now what I intended to do is I wanted to create a node pool with sandbox type as gvisor. No, you can go back to the slides itself. I can have the demo later. You can move to the slides itself. Here. Okay. I just need 2 minutes here, and then probably we can go to the demo. So I already had a Kubernetes cluster, and here if you see this particular flag, I'm just ensuring that the new node pool that I create, this should have gvisor already installed for me. And then what I'm going to do next is I'm installing the Agent Sandbox controllers and the custom resource definition. And these are the same custom resource definition that we saw, like the sandbox template and the sandbox pool and the claim thing as well. Now, once I have this, this is how you can make a claim on the Agent Sandbox. So if you see this particular code snippet here, I am creating a connection to my Kubernetes cluster. This is the Python code. I'm using the Python SDK of the Sandbox project. And then I am creating a claim onto that Sandbox a worm pool. So this is the name of the worm pool that I had defined across the slides, and I'm saying that I want to make a claim on this particular worm pool, which is present on the default namespace. Now, once I make this claim, my sandbox will be ready, and I can now go ahead and execute that code. So in this particular code snippet that you see, I am just running a command, echo from isolated container. Then I'm printing out the result, whatever results comes back from that isolated sandbox, and then finally I'm doing a termination of that sandbox. So once my task is accomplished, I can just terminate that instance so that the new worm pool or the new instance can come up for me. Let's talk about the numbers. So with the help of this worm pool claim, the overall latency of this entire process comes under a second, because now you already have the instances running for you, and your agent has to just communicate to that sandbox pool, get the code executed for you there, and just give you the response back. So the latency drops heavily here. Then with all the primitives of the the Kubernetes, we can ensure that the Linux capabilities are very minimal. We can drop them. We can disable. We can ensure that there is the file system is always read-only file system. And with this, we can also ensure that there is only one request per sandbox, which means that anytime if your agent want to execute a code, it will be always sending up a request to the new sandbox environment. So this has been the evaluation, right? How we should evolve, seeing all the issues, all the hacks that are happening in the AI ecosystem, right? Evaluation or running the agent generated code within that same app, we should completely avoid that. Having a shared long-lived container, we should again avoid that, because we don't want the different requests to share the same context. Then one hardened pod per request, it's a good idea to have that, but the true North Star would be that we should use the gvisor along with worm pool, so that we have a very minimal latency with the help of worm pool, and then the isolation or the kernel level bypass is again the kernel level access is again bypassed with the help of gvisor. So some of the notes that you can worth considering taking with you. Always have the right number for your worm pool, because you always want to ensure the latency versus the idle cost. Because if you specify the number as too high, maybe 100 as a worm pool, then if they are sitting idle, then you are wasting money there. Always ensure that the logs and the metrics of these ephemeral pods are being carried somewhere. You can have the isolation based on the namespace with all these sandbox that you are creating, and you can have the policies. For example, you can have policy related to the ingress and the egress policy, so that your container is not talking to internet or any other application within the cluster. And you should always ensure that the capacity planning is what you are doing well in advance, because you want to have a balance between the cold start versus the cost. Some key takeaways: you should avoid using in-process execution. It's an anti-pattern. Sandbox template, worm pool, and gvisor, you should use this, because this gives you a true defense in depth. You can ensure that. And with the help of worm pool, you are always going to have sub-second latency, and it makes things quite easier for you, because you don't have to replenish the worm pool. It will be automatically taken care by the agent sandbox controller. These are some of the key resources. This is the link to that agent sandbox project, and you can reach out to me over this QR code for slides and code. We can move to the demo now, and then we can have some questions after that. So I have a pre-recorded demo. Okay, so I'm just checking how many nodes I have right now in the cluster. So with this, I can see I have 5 nodes in this cluster. And let's see how many gvisor enabled nodes I have. So I should be having 3 nodes. So if I just search for this particular label, I can see that there are 3 instances, which means that I have only 3 nodes, which are gvisor enabled node. Now I'm going to install the agent sandbox controller. I'm going to install version 0.5.0. So this is going to install the controller and the custom resources for me. It's going to do a bunch of things like creating the namespace, service account, then custom resource definition, and the agent sandbox controller itself. Now, once we have the infrastructure ready, then we can start and deploy our application. Let's see what do we have here. So our sandbox controller is running. And now I can go ahead and create the sandbox template. So this is the sandbox template that I'm going to create. I'm naming it as Python runtime template. Remember the name carefully. And then I'm defining up all the primitives that we just saw: runtime class, service account token, then the node selector, running it as a non-root user, then toleration, and then the resource quota. And I'm dropping up all the capabilities so that my sandbox is with very minimal privileges. Then I'm running this particular Python runtime sandbox image. This is just a Python environment where necessary Python environment is set, like the Python is installed and all those things. Now what I'll do, I'll just create this template. So this is a blueprint that is ready for me. And after this, I'm going to create the worm pool. And let's see the worm pool configuration. So here you see, I'm just referring to my Python runtime template. This needs to be matching exactly same. And then I'm defining the replicas as 3. So which means that at a given moment, there are going to be 3 instances of my worm pool. Now, once I apply this, there will be 3 instances of my worm pool or the sandbox, and then I can go ahead and start claiming those sandbox. So this has been created. Now, if I just do a kubectl get pods, I should see those 3 worm pool. So here you can see that the first 3 are the worm pool. They just created few seconds back, which means that now these 3 instances will be always ready to serve any request. Now I'll interact with the Python code, and I'll run that Python code. Okay, so they all are running. And then I have, so in this particular demonstration, I am not using any AI agent. Rather, I'm just directly running some of the code, like the Python code and a bash command, and sending up that request to my agent sandbox. Oh, I have to deploy the router as well, because router is going to be the entry point where the client application sends that request to the router, and then router sends it to the agent controller. So router is created, And if I just check if the router is up or not. So router is again coming up, and now we are going to run the actual code. So this is the Python code. This is using Sandbox SDK, and I'm connecting it to my Kubernetes cluster via the local tunnel mode. Then I'm creating up a sandbox. I have to define the name of the worm pool. This is very important. And then I am going to execute certain code onto that sandbox. So here I'm saying that, execute this code onto that sandbox and print out the result. Then this is a bash command that I'm running. Then the other command that I wish to run is Python code. It's a simple Python code that gives you the prime number between 2 to 50. And then finally, I'm just terminating up the container. Now, I'll just run that particular instance. I've created a new terminal just to show that there is going to be a new pod that will come up. If you can see the other side of the screen, as soon as I run this particular demonstration, you will be able to see that a new container came up immediately. And this is just to replenish my worm pool. But there is one more container. I don't know if this is visible, but there is another container that got terminated. And this was the container where the actual code was executed. And here as well, you can see the responses. So this was the response that came from the container back, hello from isolated sandbox. And this was the other code snippet, the Python snippet that we tried to run, which is printing out the prime numbers under 50. So this was the sandbox replenishment that happened. A new worm pool came up. An instance came up, and the previous one executed the code and got terminated. Yep, so this is what I had for today. Thank you for listening. Thank you for staying in. And I can take up any questions if there are.
Mình sẽ có thời gian cho 2 câu hỏi.
Thank you for the presentation. I have one question: what is the different, like the advantage that you have using Kubernetes Sandbox versus something like firecrackers and micro VM with AI agents?
Okay, so now what's happening? Even if you have seen a couple of talks today, so most of the companies are already cloud native enabled. There was a keynote which mentioned that I think 90% of the companies have moved towards the cloud native, and they have already started using containers and Kubernetes. And using cloud native or the Kubernetes-based approach, there are a couple of things it helps you. First is on the operations part, because now you don't have to deal with something new. For example, Firecracker, which might be a new thing for many of the people out there. If you have already deploying your applications onto the Kubernetes, it's exactly, or 80 to 90% of that is same, just the primitives has been changed. And even the AI agents are also now being deployed onto the Kubernetes. So if you take any big companies, they are mostly trying to deploy their agents or their models onto the Kubernetes. So that gives you an advantage on the operation part, because now you don't have to deal with the different level of infrastructure, be it a bare metal VM or a Kubernetes or any other environment. So this is the benefit that you get when you run it onto the Kubernetes. You have a unified way, and it makes things a bit streamlined, because now you don't have to juggle between different things.
Có ai còn câu hỏi nữa không ạ?
Thank you for your presentation. I have a question. I saw that you are using the runtime class gvisor.
Yes.
So have you ever tried another runtime class like sysbox or kata container? And why did you choose the gvisor?
So right now the project, the Agent Sandbox project is still evolving, and right now it has been tested on the runtime class as gvisor. Although gvisor you can run it on different cloud as well. You just have to install the gvisor onto those machines manually by yourself. In Google Cloud, at least, gvisor like comes by default. Just specify a flag. Gvisor will be automatically installed for you, and you just have to create a runtime class as well. And you don't have to create the runtime class in that case, right? Runtime class will be already there. This has not been tested on other platform as of now. I have seen that in the community, since it's an open source project, in the community there are people who are trying to run this on Kata containers as well, and I think they are not having any issues or have not complained any issues onto the Kata container. But primarily, because since this project was initially donated by Google, so gvisor is the runtime class that has been tested majorly or being promoted majorly. But feel free to run it on different runtime classes as well. If you find any issues, just feel free to create a issue onto the project, and then maintainers or contributors can take a look onto that issue.
Thank you.